So thanks everyone. My name is Jesse St. Laurent. I'm the VP of Product Strategy with SimpliVity. The thought today is to give everybody a quick crash course and make sure you have the baseline on what SimpliVity is and what we do, and then go into some of the more technical details around the data efficiency stuff that we do. So specifically thinking about replication, data movement between sites, things like that. So hopefully we'll dive down into a few things that are new and some interesting topics that folks haven't seen before. So what I want to start with is a quick baseline on a quick overview on what it is that we do, and then we'll take it from there. So I think this is probably a review to a lot of folks. We'll just jump right in. SimpliVity's vision at the highest level is really about transforming IT and simplifying IT. So if we take and look at what the traditional data center stack looks like, you can separate it into kind of above the line and below the line at the hypervisor. So if we think about orchestration, management, all the things that exist above the hypervisor in the data center today, and we separate that from all the things below the hypervisor, servers, switching, storage, all those other components, all the appliances we see here, a lot of the software applications, things like data protection, replication, backups, etc. Our objective is really to put SimpliVity everywhere. So no matter what the application is, no matter what the technology is, leveraging us to provide the infrastructure for that environment. So leveraging x86 standardized systems to provide a replacement or an alternative for everything we see on the left-hand side in the stack. So all the components that we see there, really the objective of simplifying the data center. One of the questions that we get as we start to talk about this is, well, that looks like what Google does. It looks like what Amazon, pick your buzzword of the day, whether it's Web 2.0 or web scale or cloud scale or some other buzzword. So I want to take a couple of minutes and talk about the difference between the way we think about this, the enterprise space, and the way some of these other technologies work. So if we look at some core infrastructure requirements around data protection, performance, data efficiency, unified management, some of the core features that you expect out of infrastructure. And we look at the left-hand side of it, and the left-hand side is the businesses that really are basing their business on an application or a set of applications. So there's some differences. Obviously, Netflix and Facebook and Google are all very different in nature, but there are some common themes through this. And the common themes are that the actual applications were designed to run on, whether we're going to call it dumb, commodity, whatever the words are we want to associate it with, the objective is to take cost out of those core underlying x86 CPUs, drives, resources. And they've hired, all these businesses here, armies of PhDs and tremendous experts in the space to build applications that don't place requirements on the infrastructure, to really take costs out of the infrastructure. So they've implemented their own set of features and functionality. Most of them they've actually run a good number of applications, but they're really designed around the business. The business is the application. If we look at the other side of the equation, the enterprise today, in the data center, whether we think of it as a big data center or even small remote offices, most of what's running these environments is a mix of what we once called shrink wrap, although I used that term recently and realized just how little sense it makes to talk about shrink wrap software in 2015, but off-the-shelf technology, and it's homegrown applications. And in both cases, there's expectations on the infrastructure underlying it. These applications were built with assumptions about the availability, the performance characteristics, the services that would come from the infrastructure. So it's really a separation of, was the business responsible for providing the infrastructure services in the app, or did the app depend on IT to provide all of these advanced infrastructure services? In the enterprise, whether it's these off-the-shelf apps or whether it's homegrown applications, there's a dependency on the underlying components. There's an expectation on this infrastructure. It was interesting. I was at a customer a few weeks ago who says they had north of 30,000 custom applications. And they were talking about how excited they were about the progress they'd made towards running in what they described as their private cloud environment. And what they were describing is something more like the left. where they were designing applications to run without any dependencies on infrastructure, and they really built their own services around those applications. It turns out they were very excited about the progress they had made in that space. And of those 30,000+ applications, they had moved just over 50 of them in the previous year into this environment of kind of a commodity x86 with really no infrastructure services. So the other 30,000+ apps still have the dependencies on the traditional infrastructure. So the second half of this equation that I like to show the pictures because I think it makes it much more clear for folks building data centers, is if we look at the pictures of a server that you might see in a cloud data center. We notice here it's actually incomplete. There's a couple of wires that aren't connected, but the core concept is this is a server that was designed to be the cheapest possible system, right? No redundancy, 2 sockets of CPU, but only 8 DIMM slots. I'm not sure the last time anyone deployed a virtual system with only 8 of their DIMM slots populated, not particularly common, but nonetheless, no redundancy in these environments. It doesn't look necessarily like what you would see in a data center. You can see the rivets actually exposed even in this. This is a great quote from Facebook. This is an older picture of a Facebook server saying, really designed by 3 guys in a basement in California. So maybe that's not what the server looks like. Maybe it looks more like these systems. So we drill down and look at those. Folks may know this is actually a picture of a previous gen Google server. So the favorite part of this for me is that both the hard drives and the power supply and the battery that hangs off the other end of the system are all held in place with Velcro. And there's no redundancy for either the power supply, for the power supply, which in most cases is one of the most common components to fail. So this, I've yet to present to a customer who says that this is what any of their infrastructure looks like. But this is really what's the basis for these giant scale-out environments. So there's another expectation here, right? And folks have probably heard this analogy before. It's the livestock analogy of what you're building your environment for. So if your expectation is that you're managing a chicken farm, you have a very different expectation than if, say, you have a house full of puppies, right? When the DBA, the Exchange admin, the SQL admin, think of their virtual machine much like a puppy. It has a name, it does things on a schedule, it has to be fed, it has to be backed up, it has to go out at a certain time of day. There are very specific things that need to be done.
Last one.
On the other hand, the chicken farmer who gets, I don't want to do the math probably, 10,000 chickens in a barn, if 10,000 chickens don't come out of the barn in 6 or 8 weeks, they're probably okay with that. If one of them disappears, no one probably notices. But there's a very different set of expectations about what happens. When the chicken gets sick, no one takes it to the vet. Unfortunate things probably happen to that chicken. In the case of the pet, whether it's your cat, your dog, whatever how you look at the analogy, most likely when it gets sick, you go to the vet, right? Your kids cry. There's like all sorts of things happen. When the database gets sick, the DBA gets upset, and it's a very different set of expectations that come with that. So if you look at what SimpliVity's goal is and what we're doing in the market, it's really going into environments that have the stack of infrastructure we see on the left-hand side here, and replacing that set of functionality with these 2U horizontally scalable building blocks. The objective is to provide a much simpler management experience for the end user. Lowering TCO, simplifying management. So if you look at a huge portion of our value to our customers is operational efficiency. We'll go back, we'll do a demo this morning, we'll drill down into some of the details, but if we, at the highest level, our objective is to take all the traditional pieces and parts and components in the data center, allow you to buy not for 3 years from now or 5 years from now or any of the hard decisions you have to make with a traditional infrastructure cycle where you're always refreshing something, but instead start for, say, 6 months, 12 months, whatever it is that works for your business, and grow your environment accordingly as you need to scale out from there.
So would you say you sell hardware or software primarily?
Yeah, so that's a great question. So if you look at our intellectual property is focused really in two key areas. It is a software stack, and we'll drill in a bit about kind of how these pieces all fit together. But it's a software stack that runs as a virtual machine on the host. It's also an accelerator card, which a ton of the IP on the accelerator card is actually the software running on the accelerator card as well. So our stack can run with or without the accelerator card. The product in the market today, because we want to address enterprise applications, all runs with an accelerator card. But if you look at our development labs and a lot of our internal work, it happens without the accelerator card. So the value of the technology, the core IP, is around the software. From a perspective of a customer, though, and the theme of simplification, right, as the name suggests, one of our goals is simplification. We think it's much easier for a customer to consume these building blocks than it is to take hard drives and flash media and servers and software and whatever other building blocks and make their own system. From a simplicity perspective, it's easier to flip the switch, turn it on, go, have everything built, designed, all know that it's tested and interoperable. A great example of why we do that. We do a ton of testing on the products we work with, and a bunch of products that emerging, new flash technology coming to the market. We'll test the SSDs, things like that. One of the things that we found recently was we tested a RAID controller. The vendor said it's a shipping product, great product, you should use it. Okay? We brought it in, our guys ran through full QA and analysis on it and found that under certain conditions, its idea of writing the data to disk and our idea of writing the data to disk weren't the same. We actually thought when we read the data, we should get the same data back that we wrote. Their disk controller had a different view of how that should work. So that's something that would never have come up if in a kind of simple HCL approach to the market. Our guys beat the daylights out of the card, found this case, went back to the vendor, explained the scenario to them. We gave them the very explicit way to reproduce the problem, and they explained to us that they had no plan to fix it. So we explained to them that we had no plan to use their card. So that's a big part of, when you asked about kind of how it's consumed, that's a big part of why we do it that way as well. So we refer to this as the best of both worlds. So on one hand, you get the x86 commodity standardized server platforms, but at the same time, you keep all of those enterprise capabilities that you would expect from enterprise infrastructure, right? In terms of protection, performance, all those enterprise feature sets and capabilities. If you look at where our systems are in the market, they're in the core of IT. So this is a TechValidate is a company that will go out and survey your users. We went out to our user base, and this is data from feedback from them. So it may be a little challenging to see the numbers here, but it's interesting. SQL Server is running in almost 80% of our customer environments. Exchange, 50%. SharePoint, almost 40%. VDI, around 40%. And one of the things you'll notice is that there is no simple adding up to 100% here, right? It's not that these things are being deployed in pockets where they run a single application. Instead, they're almost all running in hybrid environments where there might be SQL, Exchange, Oracle, all running within the same infrastructure. So within our customers, 65% of our customers are running 100% of their applications on SimpliVity. So we're going into the market, and they're running their enterprise apps, including DR, almost universally in our customers on SimpliVity. If we take that same view of the infrastructure that I had up a minute ago, and instead of looking at it as a vertical stack, we kind of spread it out in the data center, mostly to make the animation a little bit easier than if it was all in a stack. And we look at what it is that SimpliVity does. The name of our product is called the OmniCube. This is these 2U building blocks that we talk about. The first thing we do is we add in our OmniStack accelerator. And I have one of these. We'll take a look at it in a little bit. This allows us to do what we call accelerated global predupe. So this is the deduplication, compression, optimization that we do in line before data actually ever hits the disk within the system. And I'll come back to the detailed write path in a little bit to talk about how exactly those bits move and how that all happens. But for a moment, let's just add that into the system. This is deduplication, compression, optimization once and forever. So once that data comes into our system, it's processed. It never needs to be processed again. So it's not processed in every layer of the stack. It's processed once at ingestion, and it affects every layer of the system, fine-grained level, cache, DRAM, hard drives, etc. The first thing we do then is take over the role of the traditional shared storage in the infrastructure. Right? Hyperconverged technology allows us to take over those storage systems and do it in a way that enables sizing incrementally instead of sizing kind of the big bang of a storage system. Because everything in our system is deduplicated, compressed, and optimized at inception at the time the data is written, in a lot of cases, there's no need for WAN optimization in these environments. So what we don't do, just to clarify, we don't do protocol optimization. We're not going in and trying to solve the sawtooth problem in IP, things like that. What we're doing is we're dramatically reducing the amount of data that needs to move from site to site. So if we look at, for example, a remote office environment, a lot of times remote office environments have WAN optimization devices solely for the purpose of getting backups offsite or doing replication of that data. In our scenario where we had OmniCubes in those remote sites, you really don't need the device if that's what it's being used for. Now, one caveat I will add, because oftentimes folks ask the question of, well, do I have to throw everything out to run SimpliVity in my environment? You don't have to take any of this stuff out. You could run your environment, if I go back a step, with all of these components still in the environment. Given the goal of efficiency, both on the operational side and the infrastructure side, we don't think that's the most efficient way to run it, but certainly, especially in large enterprise shops, it's a very common way for us to enter the environment. If we come down into to mid-sized companies, a lot of times all of these other devices go away when we get deployed. So back up to disk, right? These devices came along to lower RPOs, lower RTOs. Our objective is to be able to give you all that within the system. So we'll talk in more detail about how that works. But backups are an integral part of how our system works, both locally and remotely, and as you'll see in the next step, to the cloud as well. So the system allows you to connect directly to the cloud. We don't think that should be a standalone product. It should just be a feature, right? The cloud is clearly a part of the infrastructure moving forward. We can all debate exactly how, but the cloud seems to be here to stay. They'll get a new name shortly.
Based on that slide, it looks like you have to have an OmniCube at each location.
That's correct.
So if I'm a small to mid-size corporation and I don't have that type of budget, could I utilize existing hardware and maybe just buy the accelerator card? Or what can I do to make sure that I replicate between sites and not have to purchase more equipment?
So today, in order to replicate using our technology, you have to have SimpliVity on both sides of that environment. You can go to the cloud, so we can send backups into AWS today, but we can't take an existing environment and consume the storage, right? If you have, I won't pick on any vendor, but if you had servers and vendor X technology on the remote side and said, hey, could you write the data into that storage? It turns out the interoperability work to qualify that is more expensive for SimpliVity than just providing you with the system. So the level we would have to charge from a licensing perspective actually makes that not a particularly attractive option. At first pass, it looks like it's very attractive. I did a bunch of analysis early on bringing in systems and doing that type of qualification. And if you think about what our lab would have to look like in terms of cross-functional equipment, different versions of all these things, the amount of capital expense, the amount of engineering we would have to do to support all that, in the end of the day, there's a cost associated that would have to be part of the software license or the support license or whatever. The cost of the drives is far less than the cost of supporting that infrastructure.
So not even a virtual appliance or anything like that?
Yes, and not a virtual appliance today.
Okay. So you could leverage those capabilities across the WAN or whatever.
Sorry. Do you see most companies starting with production apps to use the replication if they're putting it into a larger environment, let's say, an EMC shop, a NetApp shop? How do you see most of your customers introducing the product into the environment?
So it differs by, if we just sort of generically separate enterprise and mid-market, it's a coarse way to cut it, but let's just think smaller and larger. In mid-market environments, a lot of times it's coming in for core business applications, because almost all of our customers, I don't know the exact numbers, almost all of our customers have multiple sites. So we don't go in very commonly and say, all right, we're putting a bunch of stuff in one site, because once they see the system and they start playing with the features, very quickly they're interested in taking advantage of the second site. So in the mid-market, business applications, SQL, things like that, and being replicated and protected. In enterprise shops, it tends to be a specific application development and deployment, or it might be test dev, it might be a new application that's going live, right? If we go into some, giant Fortune 100 account, as much as we would love for them to replace the entire global infrastructure with SimpliVity, that's not a realistic way to enter those accounts, right? So putting in a footprint, in general, part of our value prop is that remote site capability. So you do, whether it's mid-market or enterprise, you do tend to see that. It's the deployment is a little bit different, though. Instead of being the core mission critical app in the enterprise, in the mid-market, it is, though. In the mid-market, it's interesting. We have customers who run their 911 system, towns who run their cities that run their 911 systems. We have financial institutions that run their ATM applications off SimpliVity. So these are companies that I would describe in that mid-market space who are putting their most mission-critical apps on. And in some cases, I think we've seen from an operational complexity perspective, we lower the barrier to things like DR and replication, because a lot of our customers are doing DR for the first time ever. The complexity, the cost, it was just too much for them to bear in the past, and now, both from a skill set perspective and an economic perspective, it becomes viable.
We had a question. Sorry.
Go ahead.
We had a question from Twitter.
That's what I was going to ask.
Oh, yeah, okay. JK47. If you're backing up to a public cloud like AWS, do you need an OmniCube to restore to, or is it vendor agnostic at that point?
So today you do need an OmniCube to restore that data to. So one of the things you'll see as we drill down a bit further into the technology, anything that's processing data for decompression and optimization, as soon as you start driving data efficiency, you need some mechanism to be able to pull that data out.
Okay. So you're deduping, and you're not rehydrating it until the application's asking for the data then?
Exactly. So nothing within, so we'll show a picture of a global environment here. Nothing within our global environment is rehydrated unless VMware does a read.
Okay.
That's actually, so that one piece of information is one of the most core pieces of IP of our technology.
So is it backup to public cloud, or are you replicating VMs to the public cloud and turning them on, and can you run them?
Yeah, so it's a good question. It's backups of VMs to the cloud. You can't power those VMs on in the cloud today. And the way it actually works is, let me actually advance this a couple more pieces, and the right pieces will be there, and I'll give you the second half of that answer. So we leverage flash technology in the cubes as well. Today we use SSD. We could use a PCIe card or some other type of flash. It just happens that SSD is the best price capacity packaging of flash for us today. That allows us to get rid of some more of the components within the environment here, including the data protection apps in a lot of cases. So our customers look at data protection as this spectrum. So if we just think about that as backups for a minute, our customers fall along a timeline where some of them go in and don't change anything. Some of them put our systems in and turn backups off through all their traditional systems day 2. And then along the line, there are folks who reduce the frequency of their backups. They stop doing locals. They only do offsite monthlies. They switch to more of a mode where it becomes truly the compliance business requirement type features. But all the restores come from our system. So if we look at that, that tends to trend over time. Some customers start at the turn it all off day one. A lot of customers start somewhere else along the spectrum and kind of drift towards the direction of using less and less of that infrastructure. Very common, though, our customers will turn off their service contracts on their backup software, their tape libraries, their backup to disk devices, things like that, even if they continue to use them, because they view them now no longer being mission-critical components in their environment. I mentioned that we run a good chunk of our IP in a virtual machine. So this is our VM running on top of the ESXi. If I finish playing this forward, the VMs run on the box as well. We make those other hosts disappear, although it looks nice aesthetically. Technologically, we continue to support those hosts. So our customers have, we call them compute nodes. They can keep these compute nodes within the environment. They can connect into our data stores and get the services that we're talking about, and we'll talk more about it from a detailed perspective. The slide looks cooler though when we get rid of those and we reduce it down to just OmniCubes.
Does your VM have any kind of high availability built in for the application?
It does, yeah. So I'll go into the details of actually how component failure works and things like that in a bit later.
In this scenario here, are you looking at, like, would a customer tend to match up all OmniCube models? Or could you have, like, a lower level, I guess?
So we could have different mixes. From an animation perspective, some of this is limited by just the simplicity of animation. So we have systems that have more or less flash capabilities, more or less hard drives. They can be mixed. The general rule of thumb is the same way you would look at your vSphere cluster. You probably don't want to put a Nehalem processor next to a Haswell processor. The same thing with SimpliVity. You want to be thoughtful about how you mix those together. It all works. It's all running the same software. The question would be, do you want your Haswell system performing at the level of your Nehalem system when they vMotion, things like that?
Now, even though this is a hyper-converged infrastructure, you have the ability to use existing servers as part of it using this as a storage, correct?
Yeah, absolutely. And it's one of the things that we think is important about looking at how you practically enter a customer environment. Customers, you may not have the perfect mix of flash, hard drive, CPU, memory in perfect alignment for every customer globally. I would hypothesize that no matter how many models you have, you can't get there. So from our perspective, one of the things we wanted to do to decouple those two things was to allow customers to plug in those compute nodes. It allows them to add CPU, add memory to the environment. We bias our systems to be storage heavy for exactly that reason. It doesn't make sense to add a storage node to an environment as much as it makes sense from an economic perspective and a manageability perspective to add a compute node.
So do you see a lot of people dip their toe into this by initially buying as a storage platform for their existing virtual environment, and then start to, there's a storage platform that gives them the backup, deduplication, the DR type of capability, and over time either keep their existing compute nodes or start scaling off their compute nodes in favor of more of these nodes?
So we don't. We thought we might see that, and it was part of why we support that and the design that went into it. What we found in the market is once they get how they'll works, they're pretty excited about the concept of getting the VMs on there and starting to use it. So I've seen it a bunch of times now across customers. The simplest thing to use in the environment, the thing that just works, becomes the magnet for new virtual machines, right? So when we look in enterprise environments and it takes this long and it costs this much to get deployed on one system, each system, and the administrator says, in 30 seconds, I can spin that up for you over here. Suddenly there's this shift in resources. VMs seem to find their way to the simplified infrastructure. That's really what we've seen. We do have a couple customers who start, it doesn't last long. There are never free resources in IT, right? As soon as somebody realizes that there's CPU and memory there that's not being leveraged, something finds its way there.
And do you find a percentage of your customers use the backup to AWS option?
Yeah, I don't know what the percentage is. Most customers want to be able to do their own DR and want to own it. It's a funny, the cloud is a funny topic. So I don't think clouds are going away by any means. But as I talk to customers, the number of customers that actually want to have DR for their core business applications in the cloud is astonishingly small. So we talk to them about it. A lot of them then decide, well, I could put a cube in the closet in this sales office, or I could put a couple over here. So even the smaller customers, the bigger customers definitely aren't putting their DR there. And even the smaller and mid-market customers, one of the banks I was talking about earlier, they put backup infrastructure in a branch.
Now, are they truly using? Because when you back up to AWS, you're not doing DR to the cloud because you're not instantiating and standing up your services in the event of an outage there, right?
Correct.
You're just having a backup copy there.
You would have to restore. So we have some of our partners who actually will offer that service. So they'll basically give you DR on demand into infrastructure that's based on Cube. So we have service provider partners who will do that.
So is the backup to AWS, do you see that as just kind of another place to put some backups for safety's sake? Or because, I mean, if you have to have a cube to restore to,
What's the point of going?
you might as well just be
Sure.
another site, right?
There's some folks who just want to have want to take a copy of data on some periodic basis and just get it further away from the rest of their environment. I think.
But you also have I was reading your website, and you mentioned test dev to cloud, and that's like a perfect way to use the cloud in the places I work at. So are you thinking of doing that in the future where you can just burst to cloud essentially?
Yes, so I think it's more integration, more features around the cloud are an interesting place where we'll continue to innovate. Today it's a target for backups, and we'll see what else comes there.
At least you're not hydrating when you spool to AWS because, the upside to that is whenever you retrieve, you're not going to be charged with the full amount. It's duplicated data up there.
Yeah, so Amazon does certainly charge more on the way out the door than they do on the way in the door, but we try to make that as efficient as possible for you. So the question earlier, just to go back about what was running in the cloud, actually this SVT instance, SVT is just short for SimpliVity. The SVT instance in the cloud is the same software that's running on an OmniCube. It just happens to be running not in a high-performant way. It's running on a fairly small instance in AWS, and then the data behind that is stored into S3. So in terms of, we'll show a demo of the federation, how that's managed. The SimpliVity instance in Amazon is actually managed as another member right through vCenter, which is how we manage the environment.
What size of instance does it take?
I don't know off the top of my head. We can get that back. We can get the data back for.
So if it's just software, and you mentioned before that you could add CPU and RAM nodes essentially to a SimpliVity thing, does that actually run the SimpliVity software on the like? Can I spin up some ESX running SimpliVity without actually buying an OmniCube in order to add some extra RAM and CPU capacity to my SimpliVity environment?
You don't need anything on your guest. Your existing ESXi host mounts an NFS data store from SimpliVity. You're off and running. So we don't.
But then I don't have all of the other benefits of running the SimpliVity. Like, do I get all the global dedupe and all that?
Yeah. So you're accessing that data store. Now you're accessing it over NFS instead of going. We'll drill into a deeper diagram in a bit, but there's a network hop to get to SimpliVity at that point. But all the features and functions we talk about all work exactly the same way from a computer.
From the data level, but not from the VM level then. So I can't do VM movements around the SimpliVity side of thing. Yeah. Okay, because that's one of the issues with Hyperconverged is that you buy you get storage and compute and RAM. It's like, well, I just want some extra RAM. And as you say, there's only so many models you can have for it to actually work. It's like, I can't just go and buy some sticks of RAM and chuck it into a Hyperconverged because that's not the point of Hyperconverged. But with Enterprise, you tend not to have linear scalability. You need, I need more storage here, or I need more RAM here. So how would I...
So if what you need is CPU and memory, you just plug in the compute node. That's the design of that whole concept. You get dedupe compression optimization, data movement replication, all those features we talk about from a data management perspective all work the same way. You're just one IP hop away.
Okay.
we'll drill down. When I drill down into the architectural view, I'll come back to that and show you what that actually
Probably more the manageability that I'm looking at is because, again, simplicity, if I start adding bits and pieces to this environment, I break some of the simplicity of it. If the manageability in the tools doesn't actually work the same way.
Sure. It all works the same way. So you manage us through vCenter. So I think the next slide actually says demo. So we'll jump into a demo. We're managed through vCenter. The only thing that would look different, actually nothing would look different. You see the same data store. You do your IO to the same data store that's on the cubes as those hosts. The features and functions, you can still right-click on a VM and say backup, restore, all that stuff. Doesn't matter where it's running.
Okay, cool. So Jesse, so in a way you have two modes of operation, one being a hyper-converged appliance where compute, storage and memory is all in one, but you can also just be a SAN for existing workloads. But the advantage is if you're importing a SQL box, for example, and once that is imported into your NFS data store, that is then pre-duped and available for your global squashing the data. So you sort of have two different ways of doing it. I would think people would obviously prefer to go a hyper-converged way, but being able to act as a remote SAN is an easy way for people to migrate to SimpliVity.
It's an easy way to migrate. It's also just risk mitigation on the customer's part, right? So customers always love options, and they love the fact that they are not obligated. If they decide they need a little bit more CPU, a little bit more of this, they're not bound into our environment. So the flexibility to play nicely within their existing infrastructure is a major value. Now, we believe that they will see value in our total solution, and that over time, more and more will become SimpliVity and less will become other stuff. But that comfort level of knowing that we play nicely with the rest of the infrastructure makes it much simpler for a customer to bring us into their environment.
Thanks.
So we call it Best of Both Worlds again, leveraging off-the-shelf x86 systems, but giving you enterprise capabilities. So apologies, I think one more slide, and then we'll hit the demo slide, and we'll go into show some of those features and components. So the same picture here that we've been showing, right? The stack of legacy components in the data center. And convergence is an interesting term. It's changed in the last couple of years to mean different things from different people on different papers and different days and from different vendors. So we just start with a basic taxonomy, right? This is the traditional stack. Convergence 1.0, or what Gartner calls integrated systems, is the systems that were really pre-integration, right? You can think of them as pre-built reference architectures, whatever words we want to use, just to remove convergence as the buzzword for a minute. If you took existing technologies, wrap sheet metal, maybe some software around those, that's the convergence 1.0. It didn't fundamentally change the way the data is managed. It did change the time to deployment, time to first application up and running, things like that. So there's certainly value from a customer perspective, and there's certainly companies doing a tremendous amount of business in this space. There's a second wave of convergence, which is really taking the storage aspect of infrastructure and virtualizing it. So getting the core storage functionality up into a virtual machine. What we've done is to take that one step further. So instead of going after it with the objective of pulling traditional storage up, we thought that you need to take a step back and look at what is storage, how should this underlying component be dealt with. And our CEO, his name is Laurent, he was the CEO of a company called Diligent Technologies prior to SimpliVity. Diligent was a competitor to Data Domain in the mid-2000s. And it was interesting. One of the things that they were concerned about as a business is that somebody above them in the stack would solve the data efficiency problem. And at the time, the concern was if the backup vendors decide to somehow solve the data efficiency problem, then the Data Domains and Diligence of the world could become irrelevant overnight. So that was always a concern from a business perspective, right? The opportunity, there's so many layers between the bottom of the traditional stack and the top of that traditional stack for that data to be optimized, that there's too many opportunities to be displaced out of the environment, and it presents a business risk. So when Laurent started SimpliVity, one of the first questions he asked was, how far up the stack can you move that data efficiency discussion? because it really becomes about the data. So can you go into the applications? That doesn't really make sense, right? Can you go into the guest? That's the next logical place to put it. Turns out there's a huge amount of complexity trying to put this in the guest, right? You go down the path of doing filter drivers or some things like that. It doesn't actually make sense to deploy that way. The next step down the stack is the first time the write goes out of the VM into the ESX environment. So that's what SimpliVity's done, which is actually pull it all the way up the stack and solve that data efficiency problem at inception with the goal of never reprocessing that same data again. And we'll drill down into the details of what that means, but that's just a quick taxonomy on the space. Best of both worlds. So let's actually switch and jump into a demo. I think the demo really helps this stuff, it helps make it more real. You can see how it actually works. You can see that it actually works, that it's not just slideware.